Lesson 7-1, Multiplication Property of Exponents. In today's lesson, students will multiply monomials using the properties of exponents. Okay, so we're going to go ahead and start on page 394 and 95 if you want to follow along in your book. Before we talk about multiplying monomials, we have to understand the vocabulary of what is a monomial. Okay, so I'm going to go ahead and underline the prefix mono. What is a binomial and what is a trinomial? Okay, so you probably already know that when you're talking about a monomial, or if something starts with mono, you're talking about one. Okay, binomial means, what do you think? 2, and trinomial means 3. So it's very simple. So when we're talking about monomials, we're talking about a number. Write this down in your notes. A variable or a letter. Okay. Or the product of a number and one or more variables with non-negative integer exponents. Okay. So we've really been working with monomials a lot. You know, you work with them when you solve equations, but maybe you don't even realize what a monomial is. So here are some examples of monomials. They are single terms that either have a number, like 3, a variable, like x, or it's the product of a number and a variable. So when you look at 4y, these are being multiplied together, right? Okay, so 4y is a monomial. Now it also says that it could be the product of a number, a variable, and a non-negative exponent. So when we look at something like 5y squared, or 5y to the power of 2, that is a single term, even though all of these things are being multiplied together. And they can be a little bit longer too. You can have more than one variable and more than one exponent as long as they're positive. So if we look at 18x squared, yz cubed, all of these things are being multiplied together, and it is still only one term. It's only what? One term. Okay? So let's take a look at some of these expressions and see, are they monomials? 103. Is 103 a monomial? Is it? Yeah. It's a number, right? It doesn't have to have a variable with it. It is a single term. We call it a monomial. What about x plus 2? X plus 2. Okay? You have a variable and you have a number, but they're being added together. So really these are two terms, right? And so when we say add like terms, and you're like solving an equation or something like that, you would look for more x's to add together, and then you would add the numbers together, right? So you actually cannot add x plus 2 because this is a binomial. It's a binomial expression, no equal sign. Okay, next one, negative w squared. Negative w squared, is it a monomial? Who thinks yes? Yeah, it is. Okay, there is a negative, but there's just a negative 1 being multiplied by w. Is the exponent negative? Is it negative? No. All right, next one. Okay, w squared plus 5. Does it look like something else that we looked at before? Okay, doesn't it look like this one, x plus 2? Okay, there are two terms. How many terms? Two terms. So what do you call that? Do you call it a monomial or do you call it a binomial? Okay, yeah, so that's a binomial. So now that you know how to recognize and talk about these terms, we're going to start applying some properties of multiplication with exponents.
All right, picking up where Ms. Cochran just left off. What would happen if you multiplied 8 times 4? Well, we know what 8 times 4 is. We memorized that. It's 32. Well, you're going to be kind of doing the same type of thing with this, only now you're going to be dealing with exponents. 2 cubed actually is 8, and 2 squared actually is 4. So I really do have 8 times 4 here, it's just written differently. So you could say, well, that's 8 and that's 4, and you could do it separately, and you would get, obviously, again, 32. Or you could rewrite this as 2 to the 5th. The idea is do something like this. The exponents, because these have the same base, that they are the same number, that is, this is a 2 and this is a 2. The exponents then can add together. 3 plus 2, that would make it 2 to the 5th. You might be saying, well, that's significantly more difficult. And I'm not asking you to do it that way. I'm asking you to understand the rule. 2 to the 5th It's 2 times 2 times 2 times 2 times 2, 5 times, just like in the last video on page 389, what you already did for homework. This is 2 to the 5th. 2 to the 5th is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. The idea I'm trying to get across here is that the powers would add together. So the rule here is the product of powers property. Product of powers property. Fun to say, lots of P's. That is highly alliterative. The example that they give in the book is p to the third times p to the fifth is equal to p to the third plus 5. And I changed it to b. Ooh. Is equal to b to the 8th. All you do is add together the exponents. So what works here, numbers, letters, that's your rule. So we're going to run through a few examples and see if we can understand this. Just like Ms. Kochan was talking about like terms, we're going to apply that here. What does 5 have in common? What is it common with? Well, 5 is common with 2. So 5 and 2 are going to kind of go together. What is 5 times 2? It's 10. It's 10. Well, and then we're going to do that with the x's. I got x squared. I got x to the 4th. So how many x's do I have? Well, there's the product of powers property. We would know. We're going to go ahead and add those exponents together. 2 plus 4, that's going to give me x to the 6th. Same rule is going to be applied to the y's. I've got y cubed and y to the 6th. That's y. 3 plus 6 is y to the 9th. And that's all you're really doing on this. Move down a little bit. Let's go and try this one. Again, same idea. Combine like terms. Well, negative 3 is a number. We're going to look for the other number. That's negative 7. Negative 3 times negative 7 is a positive 21. P to the 4th is going to multiply by nothing. So that means it's still p to the 4th. It's multiplying by 1 essentially. There's no exponent to add on to it. T is multiplying by t squared. T and t squared. Remember, if it's written as t, that really means t to the 1st. Those are the same thing. So t to the 1st, so 1. And t to the 2nd, 1 plus 2, we have 3 t's. Third example. Now we have negative 5 times 2. Negative 5 times 2 is negative 10. And how many w's do you think there'd be? We got a cubed and a squared. How many w's do we have? 5. W to the 5th. And then z to the 5th and z to the 13th. How many z's would we have there? 5 and 13. That'll make 18. So that's what you're going to be doing for the first few on this.
Okay, so we're going to go through another property of exponents, and when you start to multiply exponents together but you see parentheses, this property is called power of a power. So if you have x cubed, okay, and then you see it in parentheses and you take it to the power of 5, the idea behind that is really it's repeated multiplication. So you're taking x cubed and you're multiplying x cubed by x cubed 5 times. Okay? So if you apply the property that you just learned, you would say, oh, okay, well really what I'm doing is I see 3 5 times, and instead of adding 3 plus 3 plus 3 plus 3 plus 3, the shortcut is to just do 3 times 5. Okay? So when you see a term that's in parentheses that's being raised to a power, you simply just multiply the exponents together, okay? So x cubed to the power of 5 becomes x to the power of 15. So let's go through some examples. This one looks exactly like your example, but now there is a number instead of a variable, and it's 5 cubed to the power of 10, okay? So if you use power of a power property, you say, okay, well, this is really 5 cubed 10 times. So as a shortcut, I could multiply those exponents together, and it becomes 5 to the power of 3 times 10, which is 30, okay? All right. Now, sometimes you're going to see a parenthetical expression that has parentheses outside. So 2 parentheses. Or you'll see, for example, parentheses, and outside you'll see brackets. So it's saying that you're going to have to apply it twice, okay? So there's a few different ways to do that. If you take a look at 8x in parentheses, so 8x quantity squared, and then you're going to take that quantity and you're going to cube it. You could do this two ways. Now, one thing you have to know is that if you have an exponent that is outside of parentheses, that exponent applies to everything in the parentheses. So 8x squared actually means 8 squared times x squared. And then at the end of that, you're going to raise everything to the power of 3. And you know that if you do that, you're going to do 2 times 3, which is 8 to the power of 6, times 2 times 3, which is x to the power of 6. So when you get this answer, you do not have to go ahead and expand 8 to the power of 6. You can leave it as 8 to the power of 6. Another thing you can do, depending on how what you understand best, is remember, all you're doing is multiplying exponents. So if you want to take 8x, okay, remember, it was to the power of 2, and then you multiply it to the power of 3. You just multiply 2 times 3. So that becomes 8x to the power of 6. And then you apply that exponent to both the 8 and the 6. So no matter how you look at it, it is 8 to the power of 6 times 8x to the power of 6. Okay, let's take a look at this one. So you can do it two ways. The first way, remember we talked about it, is you're going to apply the cube to the 5, the r, and the t. Okay? So this was 5r squared t cubed. So that could become 5 cubed. R to the power of, what are you going to do to these exponents? Remember, you're going to multiply. 6 and t to the power of 3. And then at the end you have these brackets and it's saying raise everything to the power of 2. So all you're going to do is multiply all of these exponents by 2. And you're going to get 5 to the power of, what? 6. R to the power of 12. And t to the power of 6. Okay. All right. So those were some examples. Now we are actually going to go through some homework problems with you so you can get some of these done by watching the video. Let's take a look at number 3. This is 5c divided by d. And it asks, is it a monomial? Okay, so is it a monomial? What do you think? Okay, the thing that makes me think no is because it has two variables. It has c and d, right? But a monomial can have two different variables because we saw it in previous examples. When you have a variable in the denominator, okay, and you wanted to bring it up to the numerator, we'll learn this property later, but if you wanted to bring everything into the numerator, it actually is d to the power of negative 1, okay, because d to the power of negative 1 is the same as 1 divided by d, which you'll learn. So does this have a negative exponent? Yes. And a monomial cannot have a negative exponent. So that is why, no, this is not a monomial. Okay. Take a look at this. This is r divided by 2. Okay, r divided by 2. Is it a monomial? Yes. And really what's happening, this is saying half of r. So it's 1/2 times r, which, yes, that is a monomial because you have the product of a variable and a number. Okay?
And we'll press on. We're going to go ahead and do a few more of your homework problems. So 11, 15, and 18. Again, if you want to locate that on your assignment, page 394 to 395. So number 11 here. Again, I have multiple exponents. I got a 2, a 2, and a 2 again out here. For me at this point, I'm still trying to go, okay, I can do one at a time. That's not going to be my favorite. So I'd rather just go ahead and multiply them all at the same time. Every now and then I notice that people start adding these. Don't add them. This is multiplication. So it's going to be 2 times 2 is 4. 4 times 2 is 8. This is 3 to the 8th. And honestly, I recognize there is not a lot of work to show. Do not feel like you need to. But I do understand the rule. So I'm not going to show anything further on that one. That would be it for 11. And you'll have a few like that go quickly. Some of them are going to be a little bit more involved, like this one. Negative 3 to the 4th, p to the 5th to the 4th, and t to the 6th to the 4th. If I got negative 3 to the 4th, what do you think the odds are I'm going to let you leave it like that? No, you're going to have to simplify that. P to the 5th to the 4th, again, you're going to have to do something with that. And t to the 6th to the 4th, you have to do something with that. So let's go ahead and simplify all of these. We have 3 to the 4th. 3 times 3 is 9. 9 times 9 is 81. This one I'd actually like you to memorize eventually. Is it positive or negative? Positive, because it has an even power. Positive 81. 5 times 4 is 20. 6 times 4 is 24. Again, what are we applying here? Power of a power's property. Last one here, number 18. Negative 3d squared f cubed g quantity squared. This whole thing? Oh, this is a monster. What should we do first? I think the first thing we should do is go ahead and take care of this part. So negative 3 squared, what would negative 3 squared be? 9. What would d squared be? D to the 4th. F cubed squared? F to the 6th. G squared? G squared. It's a good start. How about this? Well, again, you have a choice here. You could do something by cubing everything and then squaring it, or you could just start off with the 6th, which is what I'm going to do. I'm going to go ahead and make this negative 3d squared f to the 6th power, 3 times 2. Again, I'll go ahead and apply this. Negative 3 to the 6th is going to be, well, what's negative 3 to the 6th? I don't know. Same thing as 3 to the 6th. D squared to the 6th is going to be D Dwight Howard D12. And that's going to be F to the 6th. So that's this part. Let's go ahead and simplify it further. Negative 3 to the 6th. That's going to be the same thing as 3 to the 6th. I don't really have a need to go further than that. If you want to be technical, 3 times 3 times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. But it's not really necessary. So we're just going to make it 3 to the 6th, d to the 12th, f to the 6th. And we're multiplying that by 9d4f6g2. Okay, 9 and 3 to 6, those have different bases. If that's the case, one thing you might consider doing, if you're not going to simplify it all the way, is to change this back into 3 squared. That might be a little bit annoying. You might be wondering why I changed the bases. It's just because I want these to be common. 3 squared times 3 to the 6th is going to be 3 to the 8th. I have d4 and d12. This is simply that these have the same base, so we're going to add these exponents. That was in the previous section that we did talk about. That's d to the 16th. f6 and f6 is going to make f to the 12th. And then lastly, g squared has nobody to multiply by. So it simply adds on at the end. That's pretty much what you're looking at. Again, you could simplify this. I don't even remember what it is. I kind of want to figure it out though.
3 to the 8th?
Yeah, I think it's like 6,400 or something like that. But I don't remember anymore.